What's up, everybody? Welcome to the Comet ML office hours. Today, we are going to be talking about reproducibility in machine learning. So imagine that you and I are in the same organization, on the same team, working on the same machine learning project, and I give you all my code, all my training data, and then I ask you to run the whole pipeline locally on your machine. While that's happening, I go back to my machine with the exact same raw material that I gave you and run that pipeline locally on my machine. End result, we've got two models, right? The model you trained and the model that I trained, both using the exact same code and data. What would happen if we used our respective models to make predictions on the exact same validation set? You'd expect both of us to get the exact same results. I don't think it's unreasonable to think we'd duplicate our results, especially if we use the exact same raw material to build our models. And I don't think it's unreasonable to have this be the minimum requirement for our results to be believable and informative. And this is what we mean by reproducibility, but it is a challenge in machine learning and a challenge that it's actually more than a challenge, it's a crisis. It's a reproducibility crisis in machine learning. And that is the topic of today's discussion. I'm super excited to be introducing our two panelists for today. Let's go ahead and get on with their introductions. So our first panelist is a classically trained neuroscientist turned bioinformatics specialist and data scientist with over a decade of experience, contributing to the successful delivery of numerous successfully shipped data science initiatives. She's got talent ranging from product management, bioinformatics consulting, laboratory management, and technical writing. As a project manager, she brings teams together, removes ambiguity and blockers, builds confidence and trust within teams, and makes the path to success as clear as possible for team members and stakeholders. As a bioinformatics consultant, she's part data architect for cloud platforms and data taxonomies, and part software developer. So look, as laboratory manager, she's advised, assisted, and carried out experimental designs, research proposals, and statistical analyses. As a technical writer, she's developed many laboratory standard operating procedures, and as a researcher and biosafety professional. So please help me in welcoming our first panelist, Tiffany Fabianac. Tiffany, thank you so much for taking time out of your schedule to be on the show today. I appreciate having you here.
Thank you.
All right, so let's go ahead and introduce our next panelist, who's the head of research here at Comet. He earned a PhD in cognitive science with a thesis that used an early neural network trained to make analogies in symbolic relations and images. Prior to joining Comet, he was a professor of computer science at Bryn Mawr College, where he actually founded the computer science department. During his time there, his research focused on using neural networks to control a robot that went through developmental stages as it seeked out interesting aspects of the environment, which has now become the new field of developmental robotics. He's also developed one of, if not the first neural network simulators in Python, which use backprop with configurable layers. He also is one of the distinguished contributors to the Jupyter project and has worked on a project called Python Robotics. Please help me in welcoming our second panelist, Dr. Doug Blank. Doug, thank you so much for being here.
Oh, great. My pleasure. Thanks for having me.
I'm super excited for the discussion today, guys. Thank you both so much for taking time out of your schedule to join. So let's dig into this. I'm hoping that with this session, we can help share your experience with the machine learning process, with experimentation and reproducibility. And, I'd love for you to share some best practices for workflow, collaboration, experimentation, and maintenance of machine learning models in production. So let's start with Tiffany. You come from a background in life sciences, and I assume there's some clinical trials mixed in there as well. And in my time as a biostatistician, something I remember having to work on is the trial protocol. Since you're still involved in that world, can you briefly describe what purpose an experimental protocol serves?
Sure. So just kicking it off here and digging into this reproducibility crisis in machine learning, I think that the clinical trial protocol specifically is a great model to look at because they are in fact intended to be repeated, not only repeated within a single organization, if we were on the same team and I'm going to repeat your experiment, but repeated by multiple clinical research organizations across the globe. So those protocols need to be written very clearly, the methodology defined very clearly so that they can be repeated very specifically, and the results can be used to validate the research that is being presented. And there are, even within clinical trial organizations, there are still differences in what's required when writing a protocol across countries, even within organizations, between the CDC and the FHA here in the US. Even still, protocols might have differences. So even when you say a clinical trial protocol, which is so important to clinical trials, it's still not harmonized across all of those groups. But the purpose is very strongly to be repeated, but also to think through the end-to-end process. What are your objectives? How are you designing your protocol to meet those objectives? How are you going to analyze your results at the end so that you can justify what you're doing and make the conclusions that you'll be looking for at the end of the trial, and then present those to the agencies that will oversee the trials and actually approve going ahead with the trials. But it does come back very strongly to the fact that this is really something that has to be repeatable at the end of the day. So that's just clinical trials, of course. Maybe that's the golden example. But when you talk about just research protocols, again, maybe very similar to the way you would look at machine learning experiments. This is going to be a researcher who is conducting this experiment. And of course, they want to be able to go back and see how they did that experiment, go back and see how their results are interpreted, and be able to justify the changes that they see in those experiments. And hopefully other people in their lab, other people across the world can repeat those experiments. But we do see that a lot in the R&D community, in the academic community, where these very interesting articles are published, and then you try to repeat them, and for whatever reason, they're not repeatable across even different academic groups. So it's a reproducibility crisis, certainly, but definitely not limited to machine learning examples.
So how can we use this concept of, I guess, backing up there, it seems like we have this protocol to really help us ensure reproducibility. Is that kind of like the gist of why in that clinical trials world that we go through this process? Is it to help ensure reproducibility? And the piggyback question on that is, how can we use this concept or this notion of protocols, like the analog of that, for machine learning experiments?
Yeah, so I think certainly one of the purposes is reproducibility. You'll have to be able to use that protocol to communicate to the people who are carrying out the protocol what it is that they need to do, exactly what it is that they need to do, what it is that they need to look out for, what are the observations that they are collecting, so that at the end, when you have all of your data, you can put it together and make justifiable conclusions. How one of the pieces that I have certainly seen missing in my experience is, you might think about the hypothesis, and you might think about how you're going to design your experiment to test that hypothesis. But a lot of times that's where it stops, and you say, okay, this is a really interesting question. How can I address this? How can I look into it? And then you go off and you do an experiment, and you go off and you test that hypothesis. And with a clinical trial, because you're presenting this to an agency, which then has to approve what you're doing, you have to ensure the safety of the participants in the trial. You really have to think through each piece of it step by step. What data do I absolutely have to collect to be able to make the conclusions that I want to see at the end of this trial, at the end of investing all of this time and this money? What do I need to collect, and what are the risks that will come up in that? So that's maybe a step that's missing that we can think of applying to other experiments or other experimental methods. Is, are you actually thinking through not only what are you hypothesizing, what is it that you're testing, but at the end, what is the conclusion that you're looking to make, and how, if you're on the right track, how will you react if you see something different. You have to make sure that you don't have that bias. Hopefully you don't have that bias up front. And if you do, you can acknowledge it. But really thinking through the entire problem from end to end and not just, this is a really interesting question, let's try it out.
Thank you so much, Tiffany. I think that helps set the stage nicely for the rest of this discussion that's going to be going down. Doug, you come from a background in computer science, AI, robotics. I'm wondering or if this concept of experimental protocols exists in those fields and how you've seen them be used.
Yeah, that's an interesting question. And I must admit that I've worn a very different hat from Tiffany over the years. The area that I worked in as an academic in research, as you mentioned, was this area called developmental robotics. And it's really a crazy idea that you want to have this, it could be a robot or it could be just an agent of some kind, but you want it to have its own self-motivations, its own desires, its own ability to make decisions and go off and explore things. And some of the ideas of protocols in general, experimentation in general, don't fit neatly onto perhaps many different kinds of machine learning problems that people are working on. Not everything can be seen as just a set of data and you feed it in and you get a particular set of answers that you know that you want or you don't want. Sometimes you could have a system that's, well, perhaps in the future, we don't see a lot of this today, but you could see that these machine learning systems could be much more creative than we're allowing them to be today. So the question of how these protocols fit onto those kinds of experiments is really interesting. Not even about reproducibility, which is a hard problem, and we'll talk more about that, but just like coming up with like, what's a baseline? What are you comparing to? It reminds me of a story a few years ago. I was working with some students and we were exploring the idea of memory. What kind of memory does a neural network need to have to solve different kinds of problems? And we set up a problem, a robot to go down, so a light would come on at the end of a hallway. The robot would have to remember what that light was, red or blue, go down the hallway, and then turn left, it was red, turn right if it was blue. We thought, let's come up with a baseline of where we wouldn't give the robot any memory at all, and then we'll explore different kinds of memory as we go forward. So we set up this neural network that was a reinforcement type machine learning scenario, and we trained it up, and amazing to everyone, the robot was able to solve the problem without memory. So we specifically designed a problem that required memory to solve, and the robot was able to do it. And of course, the machine learning system was able to do it without memory. We explored this. How could that be? This was supposed to be our baseline. It was not supposed to work, so that when we do add memory, we can compare that favorably in a way and say, see, you need memory. And then we could explore what kinds of memory. But when the baseline works pretty well, we were left scratching our head, what do we do? It turned out that, like a lot of reinforcement learning systems, they can solve the problem in ways that humans don't think about. And it turned out the robot was solving the problem by, when the light would come on at the end of the hallway, it would immediately turn left or right instantaneously. And then it would just follow the wall. So if the light came on, it was red, it would turn to the left a little bit and follow that wall and then turn left. So it was able to use the world as memory. And so, and of course, this is well known now. It's called embodied intelligence, or there's even a nice book called The Extended Mind. But it's really a big picture about how machine learning systems and brains can work in the real world. Yeah, I think when we look at machine learning in the big picture, oftentimes we have to adjust what we mean by these different protocols, whether it's baseline or reproducibility.
Thank you for sharing that, Doug. And yeah, we spoke about baselines and the importance of needing a baseline in an earlier session. So if you guys are watching this, be sure to go and check out the session we did on baselines and the accompanying blog post for that. But something both of you guys touched on there was experimentation. And I guess that means it's a huge topic in machine learning. It can mean a lot of different things to depending on how you're viewing it. But Tiffany, you mentioned on a comment of a post of mine a while back that the data creation and collection process and model building process are likely to be different. So when it comes to experimenting with these two processes, how does your approach differ from one to the other? Then after Tiffany, we'll hear from Doug on that.
Yeah, what I was really thinking of here is experimentation in terms of you're in a lab and you're influencing the variables, right? You're introducing something that will change the outcome of what is happening in your experiment. You're introducing an intervention or something that is maybe not in the control group. And that to me is very different in terms of when you think of maybe a more traditional machine learning approach where now you have a set of data you have, or you're going to go out and collect some data. I don't know, you go to the Twitter API or you go and you scrape some news articles off of the internet, and you really are creating more of an observational data set at that point. Where I was just trying to go is it's the experimental approach is different when you're changing variables as opposed to when you're collecting data and observing. Can I classify this data? Can I predict some endpoint based on the set of data that I'm doing? And in the model building process, right, you're changing your hyperparameters, you're changing your features, you're changing the things that are being considered in the model, but those considerations aren't having an impact on the data or the data itself. The end result is changing based on how you're building your model, but the data itself is not changing. Whereas I really see when you say experimentation, it's very different than when you're planning something out and introducing an intervention or introducing a change to the control.
Thank you so much, Tiffany. Doug, I'd love to get your perspective on that. Talking about data creation and collection process and model building process, and what's experimentation look like for both those processes, and how does your approach or your philosophy of approaching differ from one to the other?
Yeah, it's changed a lot over the years. When I was a young academic researcher, I looked at these things probably the same way that a lot of machine learning, data science research groups are doing when they get started. Just doing an experiment. It's basically just a list. I've got to collect some data. Oh, it's not working. I need to clean up the data. And so these are seen as just like tasks that you have to do in order to then train your model. Oh, that didn't work. Okay, I'll change this, train the model. I guess the one thing that I've seen that really is taking an abstraction and making those two processes, both for data collection and cleaning and also model building, is the idea of a pipeline. And that might be a word that's overused. Maybe it's a little bit vague, but in my mind, I see the idea of a pipeline is an abstraction and a mechanical process of taking the let's say data and moving it through these stages in order to end up with the data that you want. And you want that to be reproducible. So the idea of a pipeline to clean up that data and send it through the pipeline is really important. But that's just a mini pipeline in a larger pipeline that involves the data set itself, but also the training of the model and the analysis of the model, and even at the end, monitoring the results of the model. So it could be what a pipette is in the science lab. It's a very little pipeline. So you could have little pipelines inside bigger pipelines. So now I see, and I would encourage people to look at the idea of mechanizing those pipeline steps so that you're going to do it again. If you're a data scientist and you're working on a model, you're going to collect new data. You're going to revise how you clean that data. You're going to build another model that's going to be better than the previous model. So you want to capture all those things that are reproducible as best you can. And so the idea of a pipeline is a really nice abstraction.
Thank you so much for sharing that, Doug and Tiffany. So I guess how can we go about defining and managing these processes in a more reproducible manner? We'll go to Tiffany and then I hear from Doug. And by the way, you guys listening on LinkedIn, you guys listening here in the Zoom room or on YouTube, if you guys got questions, please do let us know. Just drop them right there in the comment or in the chat section. Tiffany, yeah, how do you go about defining and managing these processes in a reproducible manner?
Yeah, that's a big question. There are huge companies that really make their bread and butter just by trying to address this question. And some of them do it better than others. I think in the lab, the most basic comparison here is a lab notebook, right? You have a paper notebook and you write down all of your variables, all of the things that you're considering. As much of the observation as you see is relevant to your experiment at that point. Then when you get into kind of more advanced labs, you have things like LIMS, Laboratory Information Management Systems, or ELNs, Electronic Lab Notebooks. There is well over hundreds, if not thousands, of companies that are creating these ELNs and these electronic lab notebooks to address this very question. How do you manage your processes so that it's transparent across your organization, so that your experiments and your protocols are repeatable, so that you're not running the same time trial over and over again? And it's not something that can be addressed just with the technology, right? You don't deploy a LIMS and then all of a sudden you've solved your data problem, you've solved your reproducibility problem. It's really in the culture too that you establish that you're producing data with the proper metadata tags, you're producing code with the proper standards of notation and the proper documentation, and you're really writing down all of your considerations and your user requirements and the things that are going into building that model. So it's not a quick fix. It's not just a technology. It's also a culture. And I think that academia feeds into that a lot, because this is the brightest minds in the world are coming out of academia. They're finishing their PhD and they're going into the industry. And in academia, at least when I worked in academia, the standard for collecting and documenting the data and the research protocols was so much lower than when you get into industry and you have all of these standards that you have to follow, especially if you're thinking about using that data for a clinical trial purpose. There are enormous barriers and standards that you have to follow and meet. So I think it would benefit to start in academia, establishing those standards, and the professors being able to communicate that to their students and the value of good documentation to their students, because they're going to carry that throughout their careers, as opposed to getting to industry and just saying, oh my goodness, being totally overwhelmed by the documentation and then not being able to follow or really see the value of it. So it's definitely not a simple fix. It's not a technology. It's not one thing. It's a huge culmination of culture and how we're teaching our students and the technology that we're using.
Doug, I'd love to get your perspective on that. How do we go about managing these and defining these processes in a reproducible manner? And maybe talk about like the work you've done with Comet to help ensure that these type of processes are reproducible.
Sure. Yeah, I agree with everything that Tiffany just said, but I guess I'd also like to come at it from a bit of a devil's advocate position. And yeah, I agree that there's not a quick fix for reproducibility. In fact, I would argue there's no fix for reproducibility. I would say that reproducibility reminds me a lot of computer security, and the way that initially academics paid no attention to security at all levels. And slowly security started to work its way into best practices in teaching. And so now, of course, there are entire programs, and I think a lot of people, a lot of teachers, professors introduced that early in some form. And I think reproducibility is behind the curve, but it needs to also be worked into. So I agree with Tiffany on that point. But I guess to drive home this analogy with security, the only way to have a really 100% secure computer is to put it in a room, cut off all network access to it, and just make it behind a complete firewall. Don't let anyone have access to it. Of course, that is a secure computer, but it's not very useful. So I think the same thing with reproducibility. You could have a reproducible system, but that means freezing everything. All software versions have to remain the same when we keep track of all of that information when we log an experiment. But that's not realistic. That's not useful. What you want is not to ensure that the same exact experiment is going to give you the same exact answer over time, or even on your computer and my computer. What you really want it to do, I would argue, is you want to manage the irreproducibility of a system. Software does change and you have to adapt to that. So it's not necessarily just like coming up with protocols or procedures that force the system to keep working the same way that it has in the past. What you want is, it's really a mindset so that you can continue to adapt to changing circumstances, so that the system, maybe you don't even want it to perform exactly the way that it did yesterday, but you want it to get better over time. So the idea and the mindset of reproducibility has to include the advancements, the software advances, everything keeps getting better. And so we have to adapt to that.
Interesting way to invert the problem. Instead of managing reproducibility, manage the irreproducibility. I think that's an interesting way to look at it. While we're on this topic, we'll go to Doug first and then Tiffany for the next question. And then there's a couple of questions coming around LinkedIn that I want to get to as well. But I guess, what are some challenges that machine learning practitioners might face when they're trying to ensure that their development process is reproducible, or what challenges might they face managing that irreproducibility?
Me first?
Yeah, we'll go Doug first and then Tiffany.
Okay. Yeah, I think that's the right question to ask. How do you manage irreproducibility? And in order to do that, you need data about the experiment, the scenario that it ran in. You need to know not only versions of different packages, but you need to know all of the details about a system. And in order to do that, you really need to log a lot of data about the environment. You need to log about everything that you can about the environment, and also things that humans can also note about the environment. So notes are really important when it comes to managing the irreproducibility of a system.
Tiffany, let's go to you.
Yeah, I would touch on, again, documentation. Not only the data that you're using and the characteristics of that data and the variables that were applied to that data when it was collected, the scenarios for actually creating that data, but also when the model is being built, what test cases are you looking at? And what does that actually mean? What does the interpretation of that model actually mean? Because to Doug's point here is, you can have two different models that produce different results, but what does that really mean? That they are not useful? Is it saying, are they different results but they're saying the same thing possibly, or are they different results and they're saying totally different things? You really have to understand what your model is doing and what your results are telling you. And documentation certainly helps with that. It helps with the knowledge transfer too, but also the quality of data. You have to be able to understand what your data is capable of telling you, so that you can understand what the results of your model mean. So you have to be very aware of the data and again, how the data was collected, the different variables, what they mean, so that you don't make incorrect assumptions about your model.
We talked a lot about the modeling process. Is this reproducibility aspect, maybe it's kind of redundant question here given all we've discussed so far, but is reproducibility something that we only care about in the development process? Do we care about it in other parts of the machine learning process? And then a couple of follow-up questions after that. Let's go to Tiffany and then Doug on that. And then there are a couple of good questions on LinkedIn that we will get to. But yeah, is reproducibility something that we only care about in the model development process? What other aspects would we, or areas in the process, should we keep an eye out for? Tiffany?
I think reproducibility sure is important when you're developing a model, especially important if you're trying to communicate how that model works or how it was built to your team. But when it comes to putting the model in production and you're trying to monitor the performance of that model, I don't even know how you would go about monitoring the performance if you weren't able to at least say what you're looking for, and how can you How can you establish what you're looking for if the results of your model aren't reproducible? Because you could, again, you could launch a model with just a different version of Python and get a different result. But does that mean that it's not working? Maybe the model is still going to be applicable to your use case. It just has a slightly different result. But then how do you design in a production environment the indicators that are going to tell you that model is right or wrong? Is there a value to an indicator saying that your model is just not producing what the initial model was expected to produce? You have to really define the indicators so that you're actually saying something of value. When the model is off, what does that mean? Does it mean that your data has drifted? Does it mean that you're no longer able to predict the feedback of your customers or whatever it is? So I think that reproducibility, and at least the thought process of analyzing if your model is reproducible, definitely feeds into how do you think about approaching monitoring your model in production.
Tiffany, thank you so much. Doug, let's hear from you on this. Is reproducibility something that we only care about during the development process? Maybe an interesting question, hinting towards what we're going to be talking about next week, is reproducibility in post-model deployment. Is that something that we should care about as well?
Exactly. I agree, and agree with what Tiffany said about the monitoring and how hard it is. And I guess to rephrase it a little bit, instead of talking about exactly reproducibility, but the idea of managing the changes, the irreproducibility of the entire process, the entire system, that I'd say it's really a lifestyle. It's a mindset. You have to approach everything really is, there's going to be things that change. And some of them you are in charge of, you're responsible for the changes, and some of them are not your fault. The world changes. There are trends. Humans are these very peculiar entities, these organisms that they have different preferences throughout time. So if you have a model in production that is measuring certain characteristics and making predictions, that's going to change. It's going to be different over time. I guess the question is not just how do you measure that kind of drift or errors in your production model, which some very smart people have thought about. How do you do that? And we can talk about that, model production monitoring, in just a bit. But then the question, like you suggested, Harpreet, what do you do with that information? How does that inform, to go back to the life cycle of the whole system? How does that help you, knowing that a model is drifting one way or another? How does that help you build better data sets? How does that help you build better models?
Doug, thank you so much. And some great follow-up questions I think fit nicely into where we're currently at in the discussion, coming in from LinkedIn. One is from Matt Blaza. He wants to know, how do you incorporate business user or user feedback loop into your machine learning pipelines? We'll go with Tiffany, and then we had a question from Shuaib as well. So yeah, how do you incorporate business user or user feedback loops into your machine learning pipelines? Tiffany?
I guess if I can just start with trying to rephrase it as an example, say I have deployed a model that is going to do something maybe fairly simplistic, right? It's going to try to predict what ads the user is going to click on when they come to a website. And then the user just clicks X on everything. I do that all the time. It actually brings me joy to click X on the ad and make it go away. And then does that feed into the feedback loop that Google is now going to show me different ads? I personally don't think so, because I continue to see the same ads over and over again. But ideally, that's a simplistic approach. How would you do that? But in my area, within biotech realm, how would we do that? It's much more complex than the example I gave there. So how are you, when you're trying to use a model to predict protein cleavage, for example, the user feedback is going to be based off of new data, right? You can simulate the model in a computer, and maybe the computer is feeding back new data saying this prediction was incorrect, and then you can update your model based on that prediction. You can maybe provide different weights, or you can provide a different decision for your model based on the new feedback. It's really a way of improving your model, and maybe just telling you that you need to collect more data, or you need to collect different data. Or when you're in the lab, maybe your model has predicted something, and then you go and you do the experiment to check and do your imaging, and it comes back and that's not actually the case. The protein you expected to see is not actually there. So it allows you to feed back new data into your model, which is not, it's certainly more complex than a user clicking and saying, I don't like this, but maybe the intention is the same, where there is some mechanism where you can collect new data and try to improve the model.
Tiffany, thank you so much. Doug, let's hear from you on this. When it comes to incorporating business user or user feedback loops in your machine learning pipelines, how do you think about doing that?
Go with Tiffany's examples. That's not a hat that I typically wear or a problem I have to solve. But with her examples, I think it's a really nice example of what she said with the trying to predict protein folding or something like that, and how can you incorporate users along that whole process. That's a nice example. The one example that does scare me, though, that she mentioned is how you close the advertisement box. And okay, you still see the same advertisements, but here's a related question. Could machine learning create an advertisement that you couldn't ignore? Could it learn so much about how to frame the advertising that you just have to watch it? And that's a scary question, I think, to ask, and maybe gets into a little bit of the ethics of how much do you want to include in the machine learning problem, and how much do you, and how do you respect the user in seeing things and not seeing things? That is related to this. How do you incorporate those kinds of inputs? Should you always adapt and make an even better unbreakable system, or are there ways that we can really respect the user differently than what we're trying to do today?
Yeah, I also like closing the ads on YouTube, although I'm sure my wife logs in to my computer, looks at things that she wants me to buy for her just to get the ads popping up, sneaky way about going, dropping hints. Another question coming in here from Shuaib, I think it fits nicely here as well. When you're doing hyperparameter optimization, do you consider the explainability part to ensure that even non-technical people can understand the logic or the performance increases and decreases? If so, how do you go about doing that? It's a really interesting question. We go to Tiffany and Doug after that.
Yeah, what a great question. So I think that everybody has heard that comparison, that machine learning models or AI models in general are a black box. And I think when you really think about it, even very complex neural networks, yeah, it's simple to say they are a black box, but that doesn't mean that you can't go in and analyze every single parameter, every step that the model is taking, and what weight was given to that decision, and what was the problem is that there, especially with very big models, is it becomes so overwhelming that the human brain just can't really understand what all of these different things together mean. And that's definitely a problem that we see in the biotech world, where researchers are very familiar and very comfortable with their field. They spent their entire life studying these molecules, and they know what they expect from a model, but then the model that you create for them is just going to look at the data, right? It's not going to know how the molecules work together. It's not going to know where they come from. It's not going to know all of this background knowledge. It's just going to look at the data and say, okay, I'm predicting this based on this. And a lot of times the researchers see that and say, no, this doesn't make sense. Why would that variable contribute to this model? Why would that variable contribute to the end result? It doesn't make sense. The problem there is that if you start listening to the researcher who's saying, no, only consider the variables that make sense in this scenario, then you're allowing the researcher to submit their own bias against that model. And that's something that you just have to be aware of. Maybe it makes perfect sense that a variable should or should not be considered when you look at all of the background research around that variable from a scientific sense, but the model is only going to look at the data. So when you are tweaking the hyperparameters, I would say looking at understandability and picking hyperparameters based on, does it make sense in the model? You might just be creating bias, maybe submitting your own bias or the bias of other researchers into that model by doing that.
Tiffany, thank you so much. Great question from Shuaib, and I'd love to get Doug's response on this as well. Just to restate the question, when you do your hyperparameter optimization, do you consider the explainability part to ensure that even non-technical people can understand the logic or performance increases? If so, how do you go about doing that? Doug?
It's a great question, and it reminds me of some of the tension between traditional AI and machine learning. For a traditional AI, for those old enough to remember, but back when I was in college and in grad school, AI meant symbolic AI, coming up with rules and nice, coherent explanations for a particular scenario. But that didn't work out. Machine learning, I would think a lot of people would agree these days. I was an early adopter of this philosophy that a neural network is a much better way of solving a problem than trying to find these abstractions and these rules. The idea that you could come up with something easy to understand for the layperson is perhaps not the right question. But I completely agree that explainability, understandability of what the system is doing is important. But Tiffany said it may really deal with the details of the system, and it may not make sense to a human in terms of reasoning about it. It may not be something that you can pull out and then tell a human, oh, this is how you could solve the problem. It just is not that kind of solution oftentimes.
Doug, Tiffany, thank you so much. So we're nearing the end of the hour here. So many questions left unasked. So I'm going to have a hard time picking which one to ask next. Are both of you okay just to stay over by a couple of minutes past the hour? Would that be okay?
I'm fine with that. Yeah.
Awesome. Cool. So we'll do two more questions. Just to hint, one of the questions, the last question I'll ask is about some predictions for 2022 in machine learning. So just set that bubble in the back of your mind. But I would like to hear some lessons regarding reproducibility that you had to learn the hard way. And if you could share that with the audience, because this is a topic that doesn't really get discussed much. Everybody likes to talk about how to break into data science or fundamentals of machine learning, but these more mature discussions are where all the interesting things are, for lack of better phrasing. But I'm wondering, have you learned any lessons the hard way? And can you share those lessons with us? Let's go to Tiffany and then Doug.
Yeah, sure. So I think that the biggest example that comes to my mind is that you could create a model and it could work beautifully on your data set, on your training data set. And then you deploy it and start collecting real data, and it could fail miserably. I think even the most beautifully documented model, it may possibly even the most reproducible model in the world you might still deploy it and apply it to real world data, and it might not work at all, even if your conclusions are valid, even if all of your variables make sense, even if you apply as much data as you can to it, it might still not work. And sometimes you might not understand why it doesn't work. You just have to go back to the drawing board and redraw your conclusions. It can be painful when you get to the end of that road and you've spent so much time, and you, of course, by that point are really hyping up how much this works to your organization, and then you actually get it out with real data and it doesn't work. It doesn't do what you said it does, and it really it ends up being useless, unfortunately.
How about you? Do you have any lessons regarding reproducibility and machine learning that you had to learn the hard way?
Oh yeah, far too many that we have time for. And I agree with Tiffany. I've done all of those mistakes. But I guess I'd like to answer your question by changing the question slightly. What lessons have I learned the easy way? And that makes it a slightly different problem. So here's an example that really goes to reproducibility and the importance of experiment logging and tracking. I did an experiment 6 months ago, and I used Keras, which sits on top of TensorFlow, and I was using Comet, which logs a lot of information, some that I didn't really appreciate that it logs. And I did the same experiment, exactly the same experiment 6 months later, and I got different results. You still using Keras, still using TensorFlow. The data set was identical, but I noticed when I went back to Comet and I looked at the hyperparameter logging that some of the internal hyperparameters had changed. And we don't always think about these frameworks that we use also have knobs and dials inside of them. And so it could have been a really hard problem to solve, but because if you have the ability to really look at and manage this irreproducibility, you can then see, there's something, I didn't log it myself, but the system logged it and it changed. There's a new value here that wasn't there before. And so that could have saved somebody. Luckily, I noticed it and I wasn't in an environment that was critical. So I was able to see that.
Could you share an example of one of these internal hyperparameters? Are these kind of like the default arguments that
The beauty of Keras is that some very smart people have made decisions about internal parameters. That there are a ton of little settings. There's an epsilon and a delta here and a machine. A lot of things that you think the typical experimenter, the typical data scientist doesn't have to tweak. But that's a decision that somebody made, and it probably works well in one scenario, and it doesn't work quite so well in another scenario. I don't remember exactly. I think it was one of the internal TensorFlow optimizers, Adam, had changed over time, and smart people change their mind over time, and so they make it better, and so they came up with I think it was a new implementation of the algorithm, and so it had different parameters.
So final question, we're still super early in 2022. I'm wondering what are some industry trends that you noticed in 2021 with respect to machine learning model deployment and let's just say machine learning in general that you would like to see gain more traction, and what are some trends that you wish would stop? Let's go to Tiffany and Ed.
Sure. So I think one of the trends that really has become apparent over the past few years is better, faster compute. This is great because it really allows us to run these huge models in shorter and shorter periods of time, and to really use a lot of big data. I love the idea of doing everything faster. But one of the things that I'm really passionate about that I've seen pick up more software companies, more computer companies, more websites are offering APIs into their services, allowing you to access your own data, allowing you to use some of their components outside of directly accessing their website. For example, I love that. I'm super big into trying to work out what tasks I do every day that I can automate myself. Is there any way to eliminate me needing to trash those emails that I get from people that I don't want to get emails from, all of those subscriptions that somehow I've been subscribed to? How can I make my job easier? And I think that there has been a push that I've seen lately of, companies making their software more accessible outside of just the suite that is their software, which is great. It's great to be able to access your Microsoft tools from Python and to run time tasks through so that you can predict the different things that are coming up or make your work process better. So I really enjoy seeing that within the industry, within the software tools. What do I want to stop? I'm at a loss. What do I want to stop? I think maybe just everybody saying that ML or AI should be used to fix all the things. I don't know, maybe ML is like a hammer at this point and everything is a nail. What can we hammer with machine learning, or what can we automate? I see that a lot, and especially from senior leaders, not only within my organization, but within LinkedIn, really promoting, we're going to automate everything. We're going to we're going to digitize everything. And in a lot of things it makes sense, but some things it doesn't make sense, and we have to be okay with that. I don't think that we should shy away from saying this is something that we should continue doing and not really explore automating it.
Tiffany, thank you so much. Doug, I'd love to hear from you. It's still super early, 2021, but what are some industry trends that you noticed last year, 2021, that you want to see continue in 2022? And what are some that you would wish would just stop?
Yeah, as head of research at Comet, I'm taking notes on what Tiffany said so we can help make her wish list come true. The things that I've seen over the past year that I really like, I mentioned pipelines. And I think that idea of coming up with these abstractions about the entire process, I think that's a really nice trend. It's going to help people deploy things more quickly, and not just Kubernetes or a vector, but even these little micro pipelines, just getting the idea of getting those steps in place and having a framework to do that, even if it's some framework you've created yourself and you stick to that, or maybe your team comes up with the little micro framework for that. But also thinking about not just the micro, but the mega pipeline, to see the data on one end going all the way and production monitoring on the other, but then hooking that pipeline back so it's not just a straight pipe, but a really nice life cycle. I think that's a nice trend, and I think we're going to see more of that, giving more tools to let all people in the process, whether you're a data scientist or an analyst, or if you're in charge of production monitoring, all of those groups of people can work together more efficiently and effectively. I think that would be great. The things that I would like to see change. Yeah, I agree. A lot of people look at ML as that really big hammer. I actually think it works in a lot of situations, perhaps even some that don't warrant it, but I think you can find out interesting things by using it. For a lot of data scientists, data science is such a vast area, and there's no way that any one person could know all of data scientists. So if you're getting started in data science and just a little bit, and perhaps people try to talk negatively about data science field or make fun of something that you don't know, stick with it. There are a lot of things that I don't know, and I've been working in these areas for 30 years. It's just, you can't know everything. But it's a really fun environment. And I guess I'll end on one last little bit. When I was in college, there was a humor journal called the Journal of Irreproducible Results. And it's meant to be funny. That was for a particular nerds. But it reminds me that it is something that all of science wrestles with, the idea of reproducibility and managing the irreproducibleness of it all. But it also reminds me to look at it with a little bit of humor and humility, and that we're constantly learning and getting better at this.
Tiffany, Doug, thank you both for joining us for this session. Really appreciated hearing all your insights on reproducibility and machine learning. Again, something that's not discussed quite often enough, and I'm glad we're able to get both of your perspectives on it. Thank you so much for joining us for this session. Next week, we will be back with Doug's going to be joining us again. Next week, we're going to be talking about the last mile of machine learning and beyond. And that's going to be all things production monitoring and serving and things of that nature. So it's going to be a great discussion. So make sure you guys join it. Actually, that's not next week. That's in 2 weeks, right? That's on the 23rd. Yeah, that's on the 23rd. Sorry, in 2 weeks. Next week, what we're going to be doing is I'll recap some of the discussions that we've had over the last couple of weeks. And then we're also going to do a bit of an overview and walkthrough of the working sessions that we have that accompany these office hour sessions. So my colleagues Drew and Michael will be joining us, and we're going to do a Q&A session. So if you haven't yet had a chance to check out the working session, that's all the code and actually, how we are doing this thing from a high level, right? We've talked a lot at a high level, but we've done it all in action. So check out the YouTube series on Comet YouTube for the working sessions, and come prepared with any questions you guys have. We'll be taking questions on that. So thank you all for joining us for the session. I appreciate having you guys here. Take care. Have a great rest of the afternoon, everyone. Bye.
Thank you, Tiffany. Thank you, Harpreet.